Okay, so if you recall last class, in basically this new unit is regarding collection, okay, and so what is the collection? So collection, so what we here mentioned that collection is a root interface in the collection hierarchy. Okay, and basically in Java, the collection, it represents a group of objects. And we can call them elements. So basically it's a very general representation that you can use to store a group of objects. Okay, and also it says some collections allow duplicate elements and others do not. Later on we will learn. That's in your CS3 class that do not allow. But so far what we learned, like list, linked list, array list, they allow duplicate elements. Okay, so collection here is a very general data structure here, try to represent a group of objects. Okay, so what over here we are going to learn is about this hierarchy, okay, collection hierarchy. And for this collection hierarchy, in our previous discussion, we also touched here and there about the Java collection. Okay, so over here, what we try to learn is about the collection hierarchy. So collection hierarchy, so this is interface, okay, and it's root interface. And root basically, if you recall previously, like we learned linked list, array list, those are concrete class, is it? That these support you do element by element visiting, is it? So basically that's because if you recall, we said the support iteration, is it? So iteration is the interface of iterable. And collection, if you take a look over here, it's a super interface is iterable interface. So basically iterable is collections super interface. Okay, and then under collection, we also learned a couple of interface. If you recall, we learned list interface. So sub interface is it, and we already learned list interface. And we also learned DAC interface. And we also learned queue interface. And there are some other interface that's later on, like a set, sorted set, they are going to be discussed, and the navigable set, they are going to be discussed in CS300. Okay. And list, DAC, queue, collection, iterable, they are all interface. Okay, they are not concrete class. Okay, concrete class. And if we take a look further here, so this is the official Java documentation for collection, okay, interface. And the implemented classes, that linked list we already learned, is it? An array list we also learned, like stack, is it? We also learned. So those are the concrete class, okay. And if you recall, basically for linked list, linked list, it has a feature of list, it also has features of queue, etc. And array list implements list. Okay, so this is just regarding the hierarchy. So if we understand the hierarchy better, then it helps us to also to understand how we use each of them. Okay, so that's regarding and also stack. It also implemented the collect, because collection is the root interface, is in the hierarchy, then definitely they implement. And we can take a look, like a linked list. If you recall previously, we already discussed the linked list. And the linked list, the implemented interface, is it like over here it states, it's iterable collection, deck, list, and queue, is it? And what linked list in Java, it's a doubly linked implementation of list and deck interface. Okay, so basically this is a concrete class, so it implements all the operations defined in the list interface. Okay, in the interface. And it's doubly linked, so it allows to traverse both forwarding and backwarding. So that's regarding linked list. And we also learned array list. That if you take a look, array list also implement iterable collection list, but not queue and deck. Okay, so what array list is, it is resizable array implementation of list interface. And if you recall, for linked list, so you can insert that in the middle anywhere. But for array list, so it has a keyword array, is it? So this is not a contiguous memory. But for array, it needs contiguous memory. So you have that, and so here is a resize. So if you want to expand, then you need to redeclare a new array. There's a new array, and then you can add more. Otherwise, it won't. Is it array? So that's why how array list can be expandable as each time it's resize. Okay, if you need more. Okay, not like linked list. You just create one node and then add it to the linked list. So that's a major difference between these two. Okay, so when we should use the linked list, so if your application involves a lot of insertion and removal anywhere in the collection, then you use a linked list. Okay, otherwise, if you want to have a lot of quick access of item in the collection, then you use array list, because array support indexing. And its indexing is quite efficient. Okay, so that's a major difference. And when should we choose either linked list or array list? Okay, and then let's also take a look at the list interface. And previously we also studied list interface. So now we understand it's a super interface, it's a collection, and the very top is iterable, is it? And implement a class, linked list, array list, stack. Okay, and it's an interface, is it? So list. So its major feature is it's an ordered collection. Okay, so be careful, it's order. So it's normally used to store some sequence. Okay, so sequence means item by item, is it? And for list, it also allows user to access elements by indexing. Okay, and also allows for search items. Okay. And we can also take a look at its operations. Is it has add operation? Okay, and over here, these two different. We call it overloaded methods because they have the same name but different signature. Okay, and you can also have add all method. So add all method, if you take a look, it's parameter type is collection, is the interface. It is some interface regarding collection. So if you pass in array list, that's fine because array list implements the collection. If you pass in linked list, it's also fine. If you pass in stack, it's also fine. So that's very general. So that's regarding the adding operation. Okay, it also has a search to try to find some specific item. Is it? You can also call search some collection. Is it? And equal is just try to compare. Okay, and this get is try to get specific item. Is it at you specify the index, and it can also tell you the index of some specific item. And it also has the iterator, is it? And previously we also learned, if you recall, versus iterable. So iterator is also an interface. Iterable. So iterable supports for each loop. So if some class implements iterable interface, then you can do for each loop, is it? But with the iterator, then it supports the next, has next, and remove, is it? This is especially useful if you, during the loop, within the loop, you also add or remove, then the for each loop will not support that, but with iterator, you can continue your loop, okay? Okay, so that's regarding the iterator, and it also you can also retrieve the index that with some object, and the list iterator, if you recall, then supports both forwarding and backwarding, etc. And you can also do remove, can also replace, etc. Size. And it also supports sorting. Okay, later on we will also take a look, and converting to array. Okay, so that's all of the list operation. And then linked list, array list, because they implement this list interface, so they needed to implement all of those abstract methods. Okay. Okay, so that's regarding this list, and then let's get back to the collection. And if we take a look at the collection, you see collection also has those add operation, contains, is it, and iterator, remove, etc. But some of the methods in list in collection doesn't exist. That's because collection is more general, that a list is more targeted to sequence, so ordered items. So that's why it has more operations. Okay. Okay, so, and then for linked list, previously we also studied, is it? So if you take a look, it has the implementation with the add all, is it? But it also has its own, is it? Like add first, add last. Those not existing in list or collection. So this is unique to linked list. Is it? You can add first, you can add last. So that's why we see, because they also implement DAC interface and the queue interface. So those are interface, is it? And DAC, you need to be able to support add first and add last, and queue you need to support add last, is it? That's why this part is unique for linked list, is it? And contains an element. So that's also unique, is it? Get first, get last, that's unique. And some other, like index all, those belongs to a list interface, but over here you implement it. Okay, so that's regarding the general idea, okay, about the collection hierarchy, okay. So keep this in mind, okay. So what in this unit we study is about Java collection hierarchy. So basically the hierarchy is just regarding like the inheritance, is it? And we already see, is it, the root is the collection. Is it? Under it, then you have like list. And under list, then you can have the concrete class like linked list. Is it? And array list, essential, is it? So that's regarding the hierarchy, okay. Okay, then next let's take a look the first example in this unit. The first example over here, we are trying to discuss how we use linked list, array list, okay, and also make it more general, is it? So the first one here, we have an array list created. It's an integer, and the type, we set it as a list. That's fine, is it? Because array list implement list interface, so you can do this. Okay, then you can add. So over here, we can also say it allow duplicates. Okay, and here this is number one, is it? And the type for this variable should be integer array list. And why we can do it? It's because of auto boxing. Okay, it's equivalent to you call new integer. Okay, so that we don't need to worry. So here you just do the add, and we can also do add. So this is index, is it? So kind of like insert. Otherwise, it's just add to the back. Okay, and then we can take a look this integer array list. And then what is the next one over here? We have a linked list. So this type is more general. We just make it as object. So it can have different type. Okay, so it's a linked list, but we initialize it with an array list. So linked list, it also take array list. Later on we can go back to see the constructor. Okay, so for this constructor, it takes some array list. And then if you take a closer look, this time when we do the add with the index, is it? This time it's not integer, it's a string. Why it can do that? Because anyway, string is subclass of object, as the integer is also subclass of object. So that's why this is fine. So this linked list, it's a mixed type. It has integer, it also has a string, is it? And you can also call remove last. Then we can also add first with a string, is it? Then we can take a look at this linked list. Okay, so let's take a look the running result. So if we take a look, the first is just an integer array list. Is it for the second one? If you take a look, is it has a string and integer. Okay, so that's because the type is object. Okay. Okay, then next, let's see what it discussed. Okay, so what next discuss is about that list iterator. Okay, list iterator. So if we want to get to the iterator, then you just call the list iterator method for the linked list. Is it? Then what we can do is you can check the has next and the next. Is it? And what here we try to do, okay, we try to find if it is 1, then we are going to remove it. And we can continue doing. Okay, then after we can finish, then we can output this. And we can take a look at the running result here. So if you take a look over here, so here we have 1, here we have 1, is it? Then we call the remove. If it is 1, then we remove. So here is the result of that list. It did get removed, is it? And the list is not broken, okay, here. So it can continue doing, and you remove everything, is it? Okay, and we can also uncomment this if we want to use for each loop to see if it will work, is it? So over here, we use for each loop, is it for each? And then we say, okay, if we find it, we try to remove, is it? That's our goal. Then we will see there is a problem, okay? Did you see? Then it just has a problem, okay? Run into problem this time, is it? And where it is, so it tells us the problem comes from this for each loop. Okay, so that's not allowed. So if you have for each loop, generally speaking, if you have for each loop, you shouldn't do add or remove. Okay, no add or remove in for each loop. If you do want, you need to use iterator. Okay, use iterator or list iterator. You need to use that instead, okay? And what next one try to show, if you recall, the iterator versus list iterator, is it the difference is what? Is list iterator allows traversing in forwarding, also backwarding. So in both directions, not just iterator, just forwarding. Okay, so that's a difference, okay? So what over here we try to do, okay, we set our iterator where? At the back. If you don't specify, is it like our previous one? Let's start at the beginning. And you can specify where you want to start. Is it? So here it, and then it has, you can use a has previous and previous to do the backwarding. Okay. So this is regarding list iterator, and we can go back and take a look. Oh, we need to rerun. And we can also get the backwarding result. Okay, so that's how you travel forwarding and backwarding. And what next one try to show us is for array list, linked list. So this book is customized defined class, is it? So you can also declare, create array list or linked list with some other concrete class. So here is regarding some book. This is we add some book. Okay, and when you add, you always add it to the back. Is it as a back? Then it's unsorted. Okay, so we can take a look. So here is a book. Book you add, it's not sorted. Is it? And what next to try to do if we want to sorting? Is it? And if you want to sorting, there is a function called sort function. And then you just plug in with an array list. And this sort method comes from the collections. So collections is a class. It's a class. Okay, don't get this confused with collection. This is an interface at root level. And this collections is a class. And this class, it has a group of static methods. Those methods support you do quite a number of operations regarding collection data type. Okay, so for example, sorting, you can do sorting, you can do searching. And you can do probably also like shuffling, etc. So some general operations so that you don't need to reinvent from the wheel. Okay, you can just call, and it applies not just array list. You can plug in with linked list. You can also plug in with some other data type, okay, like a vector, okay. And so basically any type that's implement the collection interface that will be allowed to be plugged in. Then it can do sorting for you automatically, okay? And for this will base the sort on what? It sort on the comparable. So the object needed to implement the comparable interface. So if we don't specify the sorting criteria, the sorting criteria, order criteria is going to be based on whatever defined by comparable interface. Okay, so then over here, let's take a look. So we have the book. Is it we wanted to sort a collection of book, a number of book. So this book, if you take a look over here, it implements the comparable interface. Okay, and because it implements the comparable interface, so over here, it implements the compare to method. So what over here is a compare criteria. The comparable interface, it's a nature ordering. Okay, so this nature ordering, that what over here means that the ordering criteria defined by the compare to method. Okay, so over here for this book, then it's using ID first. If ID is the same, then it uses name. So that's what the compare to criteria is here. And also this compare to is regarding you compare two objects. So compare to same type. Be careful, okay, same type objects. Okay, so that's what this compare to for comparable interface. And we say it's nature ordering. Regarding, okay, so it's about the same type and the criteria defined by the method. Okay, so then let's go back. Okay, and so in this sorting, so this is sorting a array list of books. Is it of book? So this sorting is based on books' nature ordering. And books' nature ordering is defined by that comparable interface. Okay, so that's all of the idea. So basically it's first on ID, then on name, is it? And we can take a look at the running result. The running results, the sort, is it? It's did first by ID. Is it? This two has same ID, but the name is different. After that, is it first by ID? Okay, then by name. Okay. Okay, so that's regarding the sorting. Then next, let's take a look at the collections. Yeah. Yes. So collections, it's a class. Be careful. Okay, class. And this class is very special. It's not like other concrete class that we learn. So this class not used for creating objects. No, it's not. Okay, because this class consists static exclusive about static method. So that all the method will operate on or return collections. Okay, collections. So what it does is it's operate on collections, is it? Or it return some collection. Okay, and the return the collection set that collection can be backed on by some specified collection. So that's what this specific class about. Okay, so then next let's take a look. So its method, it's all regarding static method. The concrete method, it also has some over here listed, is it? And let's take a look. The method, static method, it has the add all method, okay? And you can see it support binary search, is it? And regarding the binary search, so let's take a look. The binary search, and what its parameter has two parameters, is it? The item you want to search, we call it the parameter. So that's the item you want. And this is some collection. Why we know it's basically this needed to be some collection that implement list. Is it because the type is list? Is it? And that list, the object of the list needed to implement comparable. Is it? That's what we previously learned in generic unit. regarding wildcard, is it? So that's all regarding the wildcard. Okay, so anyway, so the concrete type needed to implement the comparable interface. Okay, so that's the requirement here. Okay, so this is this binary search. And the other binary search, if you take a look, it has 3 parameters. Okay, 3. And for this first one, the collection, this time, the type doesn't need to implement the comparable interface. So it's different from that one. If it doesn't implement comparable, then how you compare? So here it uses another kind of comparison. We call it total ordering. So it uses another type of comparison. We call it a comparator. And this is also an interface. And this interface supports total ordering. Okay, so it's more flexible. So this one, it has nothing to do with about this T needs to be some supports the comparable. No. Okay. And then you can specify the criteria. Okay, maybe you said, okay, I just want to based on ID, not allow name. Okay, or I just want based on sorting for name. So then it's more flexible. Okay. So that's regarding this collections. You can see it supports search. Is it? It also supports some of the we haven't learned the copying work. Is it? It also then support field work. Is it field work? Also support index work, and support you try to find the largest one or the smallest one, is it? And you can also do some replacing substitution. You can also reverse. You can also do shuffling. So rearrange, is it? So you can also do the sorting, is it? So for sorting, the one we just saw, it's by the nature ordering of the element. Okay, and the other one, then you can specify. Okay, later on in our example, we will see. Okay, so that's regarding that collections class. Okay, so basically, this collection class is just to provide you some general method. You can do some operation so that you don't need to rewrite. Okay, rewrite of the method. So basically, we can understand it provides some algorithms that support some general operations. That's what we care about. Okay. Okay, so that's for sort, is it? And then let's take a look here. So we call sort again, is it? But this time, the sort we plug in that array list, but we have the second parameter. So what is that? Okay, so here's a sort by ID. It's try to do, and the next one try to do sort by name. So after the sorting, we use it for each loop, is it? And if you take a look, the third one, we do sorting again, is it? This sort is some other type of sort, and then we can do the traversing one by one. So let's first take a look at the running result. When we took a sort by ID, you can see it's by ID, is it? And if you want to sort by name, then it's purely by name, ABC, is it? And this customized specified, and we will take a look. Looks like it's it's first based on the name. Within the name, then it's based on the ID, as it may be that we can go back to check. Okay, so how that works? So let's take a look back the book. Okay, and within the book, let's minimize everything so that we can have better understanding. So this is regarding the book class, if you take a look. So book class end here. Okay, so after the compare to method, the implementation, okay. Then within this book Java file, we define some other class, if you take a look. So here we define a class. This class is that implements the comparator. So based on this implements, then we know this comparator is an interface. And later on, we will also say this is basically also a functional interface. Functional interface means there is only one abstract method within the interface. And that's a special method, abstract method, called compare, not compare to, okay, compare. And the compare, if you take another look, you will find it's different from compare to. Compare to has one parameter. This compare, it has two parameters. Okay, so that's a different. So that's why we say compare to, it's the object itself, is it? And this comparator, it's not associated with some objects, basically. So you pass in two objects, then you specify what stuff you want to compare. Okay, and we can first go to the comparator interface to take a look. Okay, let's see, it's this one. Okay, so here we have this comparator interface. Okay, so this is a functional interface. So then let's take a look what the method is. It's an abstract method. Okay, the abstract method, if you take a look, the compare is just some generic type. That's it. It just compares two arguments for order. Okay, it doesn't care what the type is. So anyway, some type, okay, some concrete type you can specify. Okay, so that's the that is different from the comparable interface. So that's why over here, what you compare, okay, so that's why this comparator you specify, okay, it's a book, is it? Then you can plug in with two book. And then over here says, I just want to use ID for comparison. And what is the next one, the implementation for the compare, is it? It's based on the name, is it? That's what the next one is. And then our customized. So over here to implement that comparator interface, is it? So this compare method. So over here, we define some comparison. Okay, so first we have the name compare. We use name for compare. And then we have the ID compare. That we call ID compare. Okay, so what this customized compare, it first use name. Okay, first use name for comparison. Okay, so if the name is the same, then it use ID for comparison. Okay, so this is what you customize defined. Okay. And then let's see. So then now we understand, is it? So this sort method, then you can also specify the criteria for ordering. Okay, then in this case, whatever the concrete, so over here it's some concrete class, is it? So some concrete class, then it needs to implement the comparator interface. And this is called total ordering. Okay, because you can see it's more flexible, is it? Because a lot of time, if you recall online application, sometimes you want to sort by date, sometimes you want to maybe sort by volume, sometimes you maybe want to sort by name, is it? You can specify the filtering criteria. Okay, then if we call this sort, that's more convenient compared with the nature ordering. Okay. Okay, so that's regarding the two different ordering, nature ordering and total ordering. So remember, comparable interface and the comparator interface. Okay. And what next one we try to show is here we have a second array list of the book. Is it? And you can also add all. Is that add all? So add a second collection to the first collection. Okay. And what next one try to show is with collection, a lot of time we can do pipeline operation, okay, for collection. So then you first need to call the string to convert it to string. And then, so over here, you do some filtering. So we select all of the books that has the symbol as the name. Okay, contain symbol in the book name. After that, then we output of that. Okay, so in this case, we can do the chain, the call. It's pretty convenient, is it? And we can take a look at the running result, okay, for this case. For this case, okay, the previous sort we already saw, is it? And here combine two array list, is it? And then you want to find all of the books that has the same as a name, is it? Then they can pick out all of the books with the same as a name within it. Okay, then what you can do is, otherwise you need to write quite a number of lines of code. But with this pipeline operation, you see, you can just do filtering. And then you just find each of them, okay? And you can also do the map, okay? So what the map plugged in is over here. Be careful as what map can take. It can take some method. So it's some operation. You can directly plug in some operation. So basically here it says, oh, okay, I just want to have all of the name. Okay, and after that, you want to convert it to a list. Then you can call the to list from the collectors, okay, using the string. Okay, then you can next do the for each loop. Okay, so here's just to show more about the pipeline operation. And we can also call the retain all, that so retain all of the items with the specified collection, that so over here it's a list. So over here it's a retain all, it's just keep whatever in the plugged in, the second one. So this is the second list. Okay. Okay, so that's all of the